Hello, my name is Suli Kwang, and my special implementation topic is quantifying the influence of backbone pretraining for hierarchical fine-grained image recognition, or FGIR. So, what is FGIR? FGIR is a classification of subcategories from a high-level categories, such as the species of bird. FGIR main challenge is that it has small interclass variations and large interclass variations. One solution is to use hierarchical structure. Hierarchical FGIR groups similar classes into broader categories. This fixes FGR main problem, handling variety by looking at the broader categories first and makes distinguishing different classes easier. Also, at its granularity level, the prediction that the model has to make is effectively cut by half, therefore better performance. This is the structure of a typical FGR, feature extractor or backbone, produce feature representations that would be used for the prediction by the FGR module and classification head. The quality of the feature representations are determined by the backbone. Therefore, backbone choice is a very important part of FGIR. So the previous study have proven that backbone heavily influences performance for FGIR tasks. However, previous study didn't use hierarchical structure. Also, in the same architecture, different pre-training strategy can make a difference as large as the backbone family. Thus, backbone and pre-training are very important. However, searches used to find the ideal backbone and pre-training is very costly. As the model gets bigger and bigger, the bigger also the effect on the environment. So, for our objective of the project is to understand factors for the hierarchical FGR performance by studying the effect of backbone and pre-training in this task. To alleviate cost from hyperparameter search, we study the effect of hyperparameter selection on different models. To reduce future cost in the backbone selection, we evaluated 15 different metrics to predict the transfer performance for a given backbone. Moving on to the methodology, our architecture pipeline is taken from Zhang and Al's paper. It is basically feature representation is divided into n number of granularity level, and each level will be assigned its own classification heads, therefore a number of prediction. Our experiment is done with 21 models in total, 10 VITs and 11 Resnet with different pre-training strategy. We use three different data sets, aircraft, coupe, and car. These are the metrics we use. We evaluate them with top 1 accuracy with the objective of predicting transfer top 1 accuracy to reduce feature cost. We use two different settings, fine-tuning and frozen backbone. Fine-tuning use all trainable parameters, while frozen use less than 1% of the trainable parameters. We search over three hyperparameter combinations, two optimizers, two weight the case at 10 different learning rates. For the result, assuming that the hyperparameters have been chosen properly, Resnet models are more consistent than VIT, and fine-tuned models are more consistent than frozen model. Also, VIT frozen performance is approaching fine-tuned performance at a fraction of the cost. However, this is only a high-level overview. In reality, there are a large variation for each models. Despite that, both architectures obtain similar top accuracy. However, Resnet is more robust than VIT regardless of the hyperparameters. We produce extensive result for the metric and top 1 transfer accuracy. Each of these plots represent plots between the proposed metric for a subset of the model, which are grouped based on the backbone family and its setting, fine-tuned or frozen, and the transfer accuracy for the target dataset, which is aircraft, coupe, and cars. In this case, there is little to no correlation between ImageNet accuracy versus top 1 accuracy. We also did this for 14 other metrics and found the same conclusion, little to no correlation with top 1 accuracy. Now, so in conclusion, for the effect of the backbone, there are large variation for each backbones. Despite this, Resnet and VIT obtain similar top accuracy. For the effect of hyperparameter selection, discriminative models such as MoCov3 and SwaV are solid choices due to having desirable qualities for Resnet. And for the metrics, none of the metrics we have chosen have any correlation with FGR top 1 accuracy. So this is still an open issue and open for the research.